Hello everyone, this is Kalpana here. In this video we are going to see a problem from partial differential equations. So let's get going. Problem: form the partial differential equation by eliminating the arbitrary constants a and b from z equal to ax power n plus by power n. So here we are given a relation and we are asked to find or form partial differential equation by eliminating a and b from this, right? Given relation z equal to ax power n plus by power n. So here we are going to partially differentiate 1 with respect to x. So I'll show you the problem in two ways. Firstly, by increasing number of steps, and in the second way we'll see the shortcut. Okay, fine. Now let's partially differentiate on both sides with respect to x. Which gives us dou z by dou x equal to, here we are partially differentiating with respect to x, so y will be treated as constant. Okay, here y power n is constant. Now we'll write this as we have a notation dou z by dou x equal to p, so let's replace this with p equal to a is constant, write a into dou by dou x of x power n plus partial derivative of a constant with respect to x is 0. This gives us p equal to a into partial derivative of x power n with respect to x is n into x power n minus 1, right? So this gives us p equal to, right, we can write this as a into nx power n minus 1 equal to p. Now take this take this nx power n minus 1 to RHS, then we'll get a equal to p by n into x power n minus 1. Consider as equation 2. Okay, so we got a equal to p by n into x power n minus 1. We have considered as equation 2. Now partially differentiate 1 with respect to y. Okay, partially differentiating equation 1, I mean both sides of 1 with respect to y. So we can write this as dou z by dou y equal to, here we are partially differentiating with respect to y, so we'll treat x as constant. So we have constant in the first term, ax power n is a constant, plus second term. We have a notation dou z by dou y equal to q, so let's replace it by q. We'll get q equal to partial derivative of constant with respect to y is 0 plus constant b into dou by dou y of y power n, which gives us q equal to b into partial derivative of y power n with respect to y is n into y power n minus 1. Now we can write this as b into n into y power n minus 1 equal to q, right? Now take n into y power n minus 1 to RHS, we'll get b equal to q by n into y power n minus 1. So we got b equal to q by n into y power n minus 1. Consider as equation number 3. Okay. Now observe equation 1, 2 and 3. See, by replacing a by p by n by x power n minus 1, a gets eliminated. Likewise, by replacing b by equation 3, q by n into y power n minus 1, b gets eliminated, right? So by replacing a and b in equation 1, a, b, that is the arbitrary constants, gets eliminated. So let's substitute a and b here. We have 1 z equal to ax power n plus by power n, right? Now substitute a equal to p by n into x power n minus 1 and b equal to q by n into y power n minus 1 by or from 2 and 3. Right? Then 1 becomes, just replace a by this, we'll get p by n into x power n minus 1 into x power n plus replace b by the expression q by n into y power n minus 1 into y power n. See, in order to cancel x power n and y power n, we'll write this x power n minus 1 as x power n into x power minus 1. Okay. Likewise, let's write y power n minus 1 as y power n into y power minus 1 into y power n. Now cancel x power n and y power n. This gives us p by n into x inverse plus q by n into y inverse, right, is equals to p by n into, we can write x inverse as 1 by x plus q by n into, write y inverse as 1 by y, right? Now this gives us p by n into 1 by n is x, right? Or you can just write one more step. Right? Which gives us, it's z not y, sorry. This gives us z equal to p by n into 1 by x, or reciprocal of x inverse is x. Okay, we'll get x plus q by n into y, or z equal to px by n plus qy by n. Therefore, z equal to p by n into x plus q by n into y is the required partial differential equation. This completes the problem. Now let's see how to find the partial differential equation from z equal to a into x power n plus b into y power n without increasing number of steps. Okay, we are given z equal to ax power n plus b y power n, a relation. Consider it as equation 1. Now partially differentiate 1 with respect to x. We'll get dou z by dou x equal to, since we are partially differentiating with respect to x, so y will be treated as constant, right? And also a, b are arbitrary constants, so we'll write it as a into partial derivative of x power n with respect to x is n into x power n minus 1 plus partial derivative of constant is 0. Now we have a notation dou z by dou x is p, so let's replace it by p equal to a n x power n minus 1. From this we'll get p by n into x power n minus 1 equal to a. We'll just bring this n into x power n minus 1 to LHS, so that we'll get p by n into x power n minus 1 equal to a, or we can write this as a equal to p by n into x power n minus 1. We'll consider it as equation 2. Now partially differentiate 1 with respect to y. Dou z by dou y equal to partial derivative of a constant with respect to y is 0. Since we are partially differentiating with respect to y, so here x power n is treated as constant, right? So we'll get partial derivative of constant with respect to y is 0 plus, here we have y power n, right? And b is constant, so we'll let b into find partial derivative of y power n with respect to y. You'll get n into y power n minus 1. This gives us notation for dou z by dou y is q, so you'll get q equal to b n y power n minus 1. Now bring this n into y power n minus 1 to LHS, you'll get q by n into y power n minus 1 equal to b, or we can write this as b equal to q by n into y power n minus 1. Consider as equation number 3. See, we got the same thing, right? Now just observe 1, 2 and 3. By replacing a by p by n into x power n minus 1, a gets eliminated in equation 1, and here by replacing b by q by n y power n minus 1, b gets eliminated from equation 1, right? So let's replace a, b in 1. Simply we'll substitute 2 and 3 in 1. We have 1 z equal to a into x power n plus b into y power n. Substitute 2 and 3 in 1. We get z equal to, replace a by p by n into x power n minus 1 into x power n plus b q by n into y power n minus 1 into y power n, right? See, we can write x power n minus 1 as x power n into x power minus 1, so that we can cancel x power n. Let's write x power n minus 1 as x power n into x power minus 1 into x power n plus q by n into, write y power n minus 1 as y power n into y inverse. Now cancel y power n and x power n. We'll get p by n into 1 by x inverse plus q by n into 1 by y inverse. This equals to p by n into 1 by x inverse is x plus q by n into 1 by y inverse is y. Okay, therefore z equal to p by n into x plus q by n into y is the required partial differential equation. This completes the problem. See, we got the same thing. Well, we have discussed a problem from partial differential equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.